So in today's lesson, we're going to do some more stuff with factoring. Some vocabulary to start out with. A cubic equation is an equation whose highest power is 3. Or in other words, you have, for example, x cubed. That's a cubic. The second part is talking about solutions, roots, x-intercepts. A double root is where a root occurs twice. So for example, when we had something like x squared minus 2x plus 1 equal to 0, if we were to factor this, what you would see is you'd have x minus 1 times x minus 1 equals 0. And when you solve this thing, you would get a solution that said x equals 1 twice. That's called a double root. In this next group of problems, we're going to talk about something called factoring by grouping. This occurs when there are 4 different terms. So what I notice is that there are 4 terms in each case. And what you're going to do is you're going to look at both the first 2 terms in the descending order and then the second 2 terms in the descending order and treat each one as a separate group. So I look inside the red highlighted stuff and I notice that I have x cubed plus 4x squared. And out of those 2 terms, I notice that x squared goes into both of them. So I factor out an x squared, which means left over I have an x plus 4. Looking inside the second highlight with negative 7x minus 28, I notice that a negative 7 goes into both of those things. So I factor out a negative 7 and left over is x plus 4. Now if you do this properly, what's always going to happen is these 2 parentheses will be exactly the same. Always. What you do at that point, when those 2 parentheses are exactly the same, since they are the same factor, you write them down once. So you write down the thing that happened twice as one thing, and then whatever's left over that you didn't write down, or in other words, the non-highlighted thing, goes in a second parentheses. So you will see that factored out x plus 4 stuff showed up there, and then everything else that you saw showed up in the second parentheses. And that's the process every single time. Let's try this again in number 2. We're going to do a bunch of these examples. So in number 2, as I look at number 2, I have 2 parentheses again. So I have my first information here in my light blue highlight, and then my second group of information in my pink highlight. I look into my light blue highlight and I say, oh, what stuff can go into both 2x cubed and x squared? And the answer is x squared goes into both of those. That means left over I get 2x, this is absolutely, sorry, really sloppy, x squared and 2x plus 1. Now if I'm doing this right, I know that in the pink I should end up with a 2x plus 1. So I'm just going to write that down, 2x plus 1. I know that those 2 parentheses have to be exactly the same, or this is not going to work out. So if that has to be 2x plus 1, what was the number I should have pulled out? 6. Because 6 times 2x is 12x, and 6 times 1 is 6. Oh, look, I see that highlighted stuff is repeated. So what I do is I just write that down first, 2x plus 1, because that was my yellow highlighted stuff. And then in the second parentheses, I throw everything else, which was the x squared, the plus sign, and the 6, because that was all the information that was left over. Number 3. In number 3, continue with this same process. I look into my big long piece of information. I see x cubed plus 5x squared as one of the things. And then I also see negative 3x plus 15. Notice how all that stuff is in what they call descending order. Highest power, next highest power, next highest power, so on and so forth. Inside the brown parentheses, or the brown highlight stuff, I see that x squared goes into both of those things, which means that left over I'll have an x plus 5. Which means that in my orange stuff, if everything's going to work out, I'm going to have an x plus 5 as well. In order to make that work, I have to factor out a negative 3, because remember, I want these two parentheses to end up being the same. So now in the end, what I do is I write down whatever I saw in that highlighted parentheses, which was the x plus 5, because that was the thing that was the common factor that showed up twice. And then in the second parentheses, I write down everything else, which would be the x squared and the minus 3. And so everything else that didn't go in the parentheses is now in that second parentheses. Okay, I want you guys to try number 4. Okay, number 4, first two terms. First two terms I look at and I factor. You should have gotten x squared and then x plus 2. And then in the second group, if I looked at that group, the minus 9x plus 18, I know that I have to have an x plus 2, which means in the front I should have a minus 9. So I write that stuff down with the x plus 2 first, and everything else in the second parentheses. And how many people got that far? Oh, excellent. Except the one small problem is we're not done. So that's why I asked you to do this problem. I wanted to show you something. You might not have realized this, but in the last group here, the one where we wrote down the remainder stuff here that wasn't inside the parentheses that we talked about before, that green highlighted stuff can be factored again. So x squared minus 9 is the difference of two squares. That's x plus 3, x minus 3. We talked about that a few lessons ago. And we still have this x plus 2 stuff. So I just want to let you know that be careful because sometimes you can go farther. So we're going to jump to number 4 first because it has to do with factoring. And this is kind of a smorgasbord of all the different kinds of factoring we've done so far. So that's why I wanted to show it to you. So at this point, you pretty much know all the different kinds of factoring that we can do. And you have to look at something and discern which one you have to do. So I notice there are only 2 terms here. That generally is when you look for a common factor. So in the first one, when I'm solving this one, I notice that they each have an x that can go into them. So I write down x times x minus 3. And that's all you have to do for the first one. In the second one, I see 2 terms, but there's no common factor. So then I think, oh, whoa, maybe it's the difference of 2 squares, which means the first thing's a perfect square, the last thing's a perfect square, and the thing in the middle is a minus sign. Does that work? No, because there's not a minus sign in between. So this is a not possible factorization. If there would have been a minus sign in between, it would have been possible. Oh, like for example, in letter C, I notice that there are 2 terms, no common factors, but there's a perfect square with a minus in between. That means I have the difference of 2 squares, which means I'll have x plus 10, x minus 10. So whenever you see 2 perfect squares with a minus in between, it's always x in the front, the square root of the number in the back, and a plus and a minus. In D, I notice that I have 3 terms. That's called a trinomial. Generally, that's when you write down 2 parentheses as you factor. You know that you have to get the first thing, so x times x is my x squared thing. And then I need 2 numbers that when I multiply, it gives me negative 2. But when I add, I get a negative 1. So that means I have negative 2 and positive 1. This is what we call generally the general factoring Not a common factor, not a difference of two squares, but the most common factoring. Okay, so in this last one, E, is the thing that we learned today about factoring by grouping. So if I look at this stuff, factoring by grouping, and I select the first two things here in the blue, and then the second two things in the gray, it's like Civil War. In the blue, I notice that I have a common factor of 4x squared, because 4 goes into both 4 and 8, and x squared goes both into x cubed and x squared. Left over, I'll have an x, a plus, and a 2. In the gray, I already know that if this is going to work by factoring by grouping, I have to have x plus 2. And in order to get that out, I have to factor out a negative 36. So when I do this and I rewrite it, I know that my first parentheses is going to be the x plus 2 thing, because that was my common factor, the thing that showed up both times. And then in the second parentheses, I'm going to write down everything else, which was the 4x squared and the minus 36, because that was everything else that was left over. So the 4x squared and the minus 36 showed up in the second parentheses. But surprise, surprise, what I see is that the second parentheses has two perfect squares in them. 4x squared is a perfect square, and so is 36. So that second parentheses I can write as 2x plus 6 and 2x minus 6. And I still have that x plus 2 that I started with after I factored. So here's my x plus 2, and those difference of two squares turned out to be the following.